Okay, guys, here's our second concept. Our whole goal is to solve, our learning target is to solve multi-step equations here. So, again, this is our learning target, is to make sure that we can solve these multi-step equations that we are given here. And we're going to have a little bit of variation. I've got a ton of examples. There's a key on Canvas with this, but we're going to go through some of them, but probably not every single one of them in this video. So, but you guys can go through and practice some on your own as well. So, when we go to solving is we're just trying to get the unknown variable, or x, by itself. X is some value or some number that we're trying to figure out what that value is that'll make both sides of the equations correct. So, for example, I've got negative 28 equals 2x. What do I times? 2 times what will give me negative 28? That's always the question. And so we could sit here and guess and check, and some are really easy to guess and check. Some are a little bit more difficult to guess and check, as you guys can imagine. Or we can just follow our solving rules and go about solving this, okay? So generally speaking, what we're going to try to do is move the thing that is furthest away from that x, move it to the other side. So we have, if there's multiple x's, we got to get them together, but then we move everything away. So almost it's the opposite of order of operations. A lot of times we're going to add or subtract anything outside of a parenthesis or a grouping, and then we're going to multiply or divide. And we're always going to do the opposite operation to undo, because what we do to one side of the equation, we have to do that to the other side. So if I look at this first one, again, 2 times what gives me negative 28. And in your head, if you're saying, well, it's 14 or negative 14, that's correct. But here's how we go about solving this. I've got this 2 that's next to this x, which it's timesing when there's no sign in between. So I'm going to do the opposite of that, which is dividing. Okay? That cancels that out, and I'm left with just x and then equals, and then whatever negative 28 divided by 2 is, which is negative 14. And once I have one x, I'm done. So that's what that one would just be x is equal to negative 14, which we could have guessed that one. That one's easy enough to guess. Here is probably, again, for some of you guys, it might be easy enough to guess. But if not, I have this 1/5 times x equals 10. I've got to get this 1/5 away. And so there's two thought processes here. I can either times by the reciprocal of the fraction or just divide by 1/5. Timesing by the reciprocal would be to times by 5 over 1, because that gets rid of this. But I also have to times this by 5 over 1. Okay, and again, a lot of times you don't have to write the 1, but just for sake of talking, when you get a fraction that's not just over 1, that's what we want to do. So this side would be x equals, and then whatever 10 times 5 is, which is 50. And that would be my answer. Okay? If we look at this number 3 here, I've got a few different things. I've got negative 3x minus 2 equals 7. So in this case, I've got only an x, but I've got two things on that same side. So I need to move the thing that's furthest away, or think of it as undoing order of operations. So I need to look at any addition or subtraction. There's a subtraction right here. So I need to move this subtract 2 to the other side. How I move it is I do the opposite operation. I add 2 because it'll cancel it out or make it 0. But what I do to one side, I have to do to the other side. Okay? Then we are going to rewrite. So this will be 3x equals 9. Okay, now I'm back to the exact same problem that I had with number 1. So negative 3 times x. Again, that would be my next thing. So I do the opposite operation, which is divide by negative 3. But what I do to one side, I have to do to the other side. So this will give me x equals negative 3. Okay? So that's how we look at those for that. Moving in progression and getting a little bit more difficult, if we look at this fourth example here, I've got multiple x's. So I want to get the x's together. And it doesn't matter whether you put them on the left or the right. Generally speaking, I try to keep them positive. So if I have a positive 3 and a positive 2, and I know I've got to do the opposite operation to move it to the other side, I'm going to move the smaller number. So in this case, I'm going to move the 2x by subtracting 2x in this case, because that cancels that out, and all I'm left with is just 5 on this side. And then on this side, I have 3x minus 2x, which gives me x, because I can combine those two, but I can't combine this plus 2 because it doesn't have an x. Okay? And then once I get to this point, I've got almost x by itself. Remember, the goal is always to get that unknown variable by itself. In this case, it's x. So I've got to move this adding 2 to the other side. So how I do that is do the opposite operation, and that's subtracting. So I'd have x equals 3. Okay? All right, let's look at, so 5 is pretty similar. Let's look at number 6 that has multiple x's as well. So I've got negative 10 plus x plus 4 minus 5 equals 7x minus 5. So again, I have the 7x and the 1x. Whenever there's nothing out front, it's just a 1. I've got to get those two together. I'm going to minus x because 7 is bigger, and that'll keep this thing positive to 6x. And then I'm going to rewrite. So I drop the negative 5 down, drop my equal sign, and then I have this negative 10. I have a plus 4 and a minus 5. Now I'm going to get everything on this left side. Let's clean this left side because we have just no x's here, so I can just simplify this with my order of operations. So all it is that is subtracting, so I work left to right. So negative 10 plus 4, which is negative 6, and then I'm going to minus 5, which would give me negative 11, and that's going to be all equal to 6x minus 5. And then I just have to do my opposite operation. So I'm going to add this 5 because I need to move away from the x. So add the 5 here, which will give me negative 6 equals 6x. And then I divide by 6, and that'll give me x equals negative 1. Okay? Okay, now introducing things with parentheses. Again, there are two ways about going about this. You can either just move the 3 right now, or you can distribute it through if you'd like and get rid of the parentheses. I'm good either way. It'll get you the same results either way. I would just look at this and say this is 3 times x plus 2. Again, the x plus 2 cannot combine, so I can't simplify those two, and then it's equal to 11. So this 3 parentheses, that's timesing. So I would just get rid of that 3 right now by dividing, because it's timesing. And so I'm going to have x plus 2, and then that's going to equal 11 over 3. And again, if it tells you that you want to round to the nearest hundredth, then you're going to want to figure out what that is. This is 3.6 repeating, but if it's rounded to the hundredth, we'll just go 2 places. And then the last thing I have to do is get rid of the plus 2 by subtracting 2. That'll get rid of that, and I'll have x equals 1.67 is what I have for that. So again, that's how I would deal with those parentheses. Again, you can actually just distribute this 3 through and then subtract and divide, and it'll give you the same thing. I just feel like, again, I feel like solving is, instead of guessing and checking, is like a shortcut, and so we might as well do it the shortest way possible that we can. Okay. Let's look at this number 10 here. So number 10, I have parentheses, and then I have no parentheses. So I'm going to take care of this parenthesis. This one I have to distribute. It just makes it easier. So I'm going to distribute that. That's what I'm talking about, what we could have done on number 7. So for this one, I'm going to go negative 14, because 7 times negative 2 is negative 14x. And then 7 times 2 is 14. So that gives me that expression, and then I'm going to rewrite. Rewriting is a great idea to do every time. And then as I look at this expression, I've got to move my x's to each other like we did up here on number 6. So you guys can see we're just adding on some difficulty as we go. So I have 4x and I have negative 14x. again, I like to make it positive, so I'm going to move the negative 14 to the other side, to the bigger number. So I'm going to add 14x because it's subtracting. And what I do to one side, I have to do to the other side, but only to the x. So that'll give me 18x minus 40 equals 14. Okay, now I need to take care of this minus 40, so I'm going to add 40. What I do to one side, I have to do the other side. And then I'm going to be left with 18x on the one side equals, that would be 50, again, 54, okay? And so as I go to this last step, I'm looking to move the 18. The opposite of timesing is dividing. Again, I know this is timesing because there's no sign in between, so what I do to one side, after the other side, I have to divide those, and that gives me x equals 3 in this case. Okay? That is what we're looking at with those, okay? Don't be shy. This 13 is a lot like number 2 that we did. We're just going to times by a reciprocal. That reciprocal would be 5 over 4. Let's just do that right now. So if I times this by 5 over 4 to get rid of this, it cancels both those out. And I'm left with x on this side. But what I do to one side, I have to do the other side. So I'm going to times this also by 5 over 4 as well. And when I do that, when I simplify that, that gives me just 5. Okay. This number 14, again, this is just dividing by 2. Again, how do I move a divide? Well, I just do the opposite operation by timesing. Because that'll cancel that out, and I'll be left with x equals whatever that is, which is 46. Okay? Okay. Let's look at this next page here. Look at a couple others that might be a little bit more complicated in that way. Okay? So let's look at 15 here. Well, yeah, let's look at 15. Well, look at 14 and 15. So 14, the fraction is just on the x. On 15, the fraction is over both of them. So if you're looking at 14, I have to move this minus 14 first. Whereas if I'm looking at 15, I have to move the 9 first. Okay, so here's how this would look. For this one, I would add 14. Okay, and I'd give x over 3 equals, because that cancels out, that equals 12. And then I have this divide 3, so I'm going to times by 3, because that'll get rid of that, and I'll be left with x. Again, 12 times 3 is going to give me 36. So that's how that one looks, because the fraction's only over the x. On 15, though, the fraction's over the whole thing, so I'm going to start by getting rid of the 9. So I'm going to times by 9. Okay, and I'm going to have 8x minus 2 equals 54. And then once I get done with that, I have to now move. This looks a lot like what we did in the front. So a lot of times when I have these fractions, all it is it's an extra step, and then it looks a lot like we did on those first problems. So I've got to get rid of the minus 2 by adding 2. So I'll have 8x. Again, those get rid of, equals 56. And then divide by 8. And you have to divide by 8, obviously, with both sides as well. And you get x is equal to 7. So that one looks counter from what it is, but really, in reality, that's what you're looking at. So if you have something like 14 where you've got to take care of this adding, subtracting first, which in this case is subtracting, whereas this one, the fraction is the whole thing. And so you just go right to the fraction. Okay? Hopefully you guys can see the difference between those. One last that I want to look at is number 17. Number 17, I have this fraction. I'm going to get rid of the fraction by timesing by 2. And then I always have the question. So that gets rid of that. And I'm left with 3x plus 9. I always give the question like, what do I multiply it to? In reality, you put parentheses and you have to multiply it to both things. Okay? So this will give you 18 minus 8x. And so you have to multiply it to both or everything that's over there. And then once I get to this point, it's a lot like ones we've already seen. I'm going to get the x's together, and because I have this smaller negative 8, I'm going to add 8x. Add 8x. Again, that'll cancel that out. I'll be left with 18 here. left with 9, and this will be 11x. Then I need to move the plus 9, so minus 9, and I get 11x equals 9. And then the last thing to do is divide by 11 from both sides. So I'm going to divide by 11 because that gets rid of that timesing. And I'm left with x equals, again, you're going to get a decimal for this, 0.81 repeating. And so that's what you'd have for that one. Okay, so there's a lot of different, there's a lot of different ways, but again, hopefully this will kind of help you guys with the fractions, with the others, those type of things as well, okay? Anytime you have parentheses, we've kind of looked at that as well. I think that kind of wraps it up. So again, your learning target is to be able to solve multi-step equations with parentheses, with fractions, with adding, subtracting, multiplying, dividing. So, all right, we'll see you later. Bye.